Okay, got the right cannon built. This is in the upright position. We'll just move it back to neutral. Boom. So I get the cannon and everything. I'll okay, hit home again. I added some detents, some spacing on the numbers for everything to make sure accidental presses didn't cause it all to move. And there goes that. Just a moment. Make sure we don't. Black, brown. And now that it's up, we do this. For testing, I went ahead and wired in the joystick to the right cannon. I got a gyroscope coming in that'll allow for head tracking movements on the right cannon. It's going to be a Predator 2 one. Found a nice 3D print off a CG trader that works. Let's see. That's copyrighted. Let's go ahead and this is the script. So we'll go ahead and start her up. And everything just moved into neutral. It's all normal. There we go. Just a simple 20-watt build I got. Just go ahead and kill that. Just give some good close-ups on everything. It's a 4700 microfarad cap. I'm gonna redo some calculations, see if I need more with the draw. This is the most powerful servo I can find in the market. Unfortunately, it's out of China. Hint, hint. Figure out a way to make it here. That's also made out of China. That's about 50. This one's about 14, 15, 20. Everything else I've tried to source from either Adafruit or Servo City so that I can say it's off the shelf. I did have to do some minor cutting to make things work. Big whoop. The gearbox I had a special order from Servo City because they discontinued it. They got a whole setup that's got a potentiometer in here, and I just needed a solid 2-inch shaft so I can make everything work, because it just static mounts here, and then this just spins around there, and I got some polyurethane spacers there. I just don't like to have any sloop or spare space. It causes premature wear when you factor in torsion, other issues. Still tweaking it. Once I get the cannons mounted, I'll figure out what final torque settings I need to do on it and get it working. This is just a simple mock-up I built, learning from last time that you have two built setups, you have them identical, then you can rub parts if something breaks in the field, which to me, field repairs and the ability to do field repairs expediently is very important. That's running at 12 volts DC. It's basically putting out 20 watts to that single speaker. Works great for testing the sound output. Other thing to note here is This little unit here is HDMI to VGA with audio out. And that's coming off of an extent cable setup and whatnots from Adafruit. The key is to remove as much strain from all the connectors as possible, because you will have momentary strain and you want to eliminate that as much as possible. Have breakaway connectors. Big thing in the laptop world, never really caught on much, but it is what it is. The servo bonnet's there. I kind of like this setup more because all of the sound, all the controls, everything's done to the Raspberry Pi, and as you could see, there was no real delay in the script. I'll just go over the script. Okay, this initial script was written by Matt Hawkins. He's expressed interest. This is just, there's where you import all the, there we go, there's cursor. There's where you import the different functions. There's where you name the various functions. There's where you get the neutral positions for all the servos. It's very important at the beginning of any given script to zero the servos out in case you're at max. Then you can quit, and it, you know, if anything's out of spec, it's easy to recalibrate. Button delay is just a placeholder for time sleep. Those are the button counters. Those are just variables. You have to set an initial value so that the script works right. Those are the 20 or so sounds that I've added. The waves are played with A play, except if it's a non-PCM or float encoded, in which case I have to use M player. The MP3s are played with MPG 123. These are all songs and sounds that I have legitimately purchased. I do not believe that it's right to pirate anything, whatnot, yada yada. And this is, you know, where the script starts. It tries to connect, and then if it doesn't connect, it quits. It gives that display, and then while true basically runs in infinity. That's where you get the battery and the buttons, dictionaries to pull your values from. There's where you pull the accelerometer readings, the nunchuck buttons. The nunchuck was the way this report is it's got the actual Wii, then the accelerometer, and then the nunchuck. The nunchuck is its own self-contained library and does its own little thing, so you have to call it out specifically. So here's where you extract the dictionary, and then from that dictionary you can pull the button status and the accelerometer status. Same for the stick settings for the nunchuck. This is where you recalculate or remap the values so they're 0 to 180. This is just a simple remap function. It's a simple polynomial. You just plug in the values and away you go. Those were some. That's not used. The Wiimote accelerometer was meant to be used with an IR pointer, so those readings aren't really that good. This is where the home, this was a lot of trial and error, so at 0 it's at that initial position, so if I hit it once and it reads it, it moves things up, otherwise things stay in their neutral position. Okay, I might move that. This is the quit it. So basically it just exits the Wii and away it goes. That just basically makes it continuously rumble. If the battery below a certain value, lets you know it's time to replace the battery. That's just an explanation of the script. The way that I had to do it here is check stat read, increments it, then if it equals 2, it does that action, and then gives you a status update, on and on. I had to add a padding of 3 and an increment of 1, otherwise it would play the song multiple times. This was the cleanest way that I could do it with the code. And I had to use a subprocess command to play the files, because you go here, create subprocess, opens that, and it plays that with the quiet option and the name that's specified above. And there's the home. You know, if it's 0, it's zeroed out. If it's 1, it goes there. And then if it's 2, it just resets it to 0. As you can see, I added plenty of sounds to it. So, button C, Z, there's Z, there's C, and there you go. Have fun.